going to go over the transforming functions exercises from week 16. And in this assignment, you are going to use the Sketchpad tools to see what happens when you transform functions and to see if you can figure out what kind of a transformation it was. Was it a translation, a reflection, or a vertical stretch, or a vertical shrink? And we're also going to write about like how, did it reflect over a certain line? Did it translate by so many? Did it shrink by so many? So what we're going to do, first of all, this is the parent function. So this right here, f of x equals x squared, that's what the most basic parabola quadratic function you can make is. So that one's already there. Now we're going to change it to y equals 2x squared. So here's what you do. You go to graph, plot new function, and then you're going to type in the part after the equal sign. So 2x, that's the squared button, is this little thing, 2x squared. And it should look like it says g of x instead of f of x because it's going to be a transformation, so they need to change the f of x to g of x. It doesn't matter that ours says y. That's just another way of writing it. And then we hit OK. And I'm going to change that to a different color by going to display, color, and I'll change it to, I don't know, how about red? And I'll change it also to a fat. A little bit fatter. There we go. Okay, so the red one is the transformation. So you wrote that the graph is a lot skinnier, and you are correct, it did get skinnier. So what we need to do is say, well, that's true. What is that called then? That's called a vertical shrink. So instead of just saying that the graph is skinnier, we're going to say vertical, spell it right, vertical shrink. My goodness, my spelling is terrible. Vertical shrink by a factor of 2. Here we go. By a factor of 2. There we go. Now we're going to move on to the second page. There's page tabs at the bottom. Okay, the second one, this is the absolute value function. And the absolute value function looks like a V. Now again, this is the parent. This is just y equals absolute value of x, or f of x equals the absolute value of x. So that's our parent function. And then we are going to graph this one here. So we are going to see how, go to graph, plot new function. And we're going to put the part after the equal sign. So y equals. So we're just going to type in the 0.25. Now to find the absolute value bars, you have to go to functions and then click on abs. You see that? Functions and then abs right there. That's absolute value. And now we're going to put the part after the absolute value sign, which is x minus 2. And you'll see that up here, that looks like this. And then after the absolute value function, so we have to click outside of that parentheses, we are going to put a plus 1. And when you type the plus 1, you're thinking, that's going to move it 1. Is it going to move it up, down, left, right? It's going to move it, isn't it? Also, the minus 2 is going to move it. And the 0.25 is going to do something to it. So let's see. You know what? I'm going to take the plus 1 off. Oops, I need my parentheses though. Okay, this is just this part. I didn't do the plus 1 yet. I just want to see what this looks like. Ooh, it's very flat. You're right that it's very flat. I didn't do the plus 1, remember, but it flattened it out a lot. So it really compressed this. It pushed it down towards the x-axis. So that is a vertical compression. And I bet you can see the factor. The factor is 0.25. So a vertical compression. And it's a compression because it's less than 1. 0.25. Okay, it also has a translation. We can tell that this function moved because before, look, the vertex where this v ended was right at 0, 0. Now it's over here at 2, 0. That minus 2 here, inside here, and here it is 2, minus 2, moved it to the right. Translation to the right. Translation is when you move it 2 units. Now remember that I didn't put the plus 1 on there. I'm going to go and I'm going to get my arrow tool over here, and I'm going to click on my function right here, and I'm going to put that plus 1. And then we'll see what does that do to it. Look at that. It was down here. Now it moved it up. So not only did it have a translation to the right 2 units, it also moved up 1 unit. Now we have a good description that has the words, vertical compression. It's got the translation, how many units right and how many units up. It's got everything we need. It also has the graph, which you need too. So I'm going to try to change this. That's not what I wanted to do. I wanted to change, but it was still typing. It was 1 unit up, right? Unit up. There. Now I need to get out of my box. There. Okay, I wanted to select this and change it to my dark red again. Display, color, it was that kind of burgundy color, just so I can tell that this is the one that has been transformed. That's my new one. Okay, and then you'll do the same thing for page 3. And see, it's going to do more than just get wider. It's also going to, this +4 is going to do something. And the get wider part is what you call a vertical, oh, they don't use compression, they use shrink. So a vertical shrink is when it gets wider. A vertical stretch is when you're multiplying by something bigger than 1. And the translation is if it moves left, right, up, or down. A reflection is if it gets flipped about either the y-axis. If this one got flipped about the y-axis, it would look the same. But you could flip it about the x-axis and it would be upside down. Number 4, -3 times x plus 1 minus 1. There's going to be a translation in this. This one may have a reflection. Let's type that one in quick. Let's see what this looks like. So again, your first step is to plot it and see what it looks like. But you're also maybe kind of thinking about, I think that negative something, that's going to do something. Absolute value of x plus 1. I know the plus 1 is going to translate it, and the minus 1 is going to too, but let's just do it. Put the whole thing in here. Now see, I made a mistake here. Now it looks like x plus 1 minus 1. Right here, I was supposed to get out of that before I typed in the minus 1. But now you look up here, and now it matches. So I'll hit OK. And there's, look, it did reflect it about the x-axis, because that means if it's upright, opening upwards, and now it's opening downwards, it's upside down, then there's a reflection about the x-axis. So when I type the description for this one, I'm going to say reflection about the x-axis. It's a translation to, let's see, how did it move? Look at the vertex. Here's my vertex right here. My vertex was there, now my vertex is here. It moved down 1, and that's because of the minus 1 right here. It also moved to the left 1, and that's from the plus 1. It does the opposite of what you might think. So it's a translation. You'd say down 1 and left 1. There, that's what you write. Okay, and then number 5, let's just peek at that one. Okay, so for 5 and 6, what you're going to do is you're going to write the equation. Now these are a little bit tricky. We're going to see if we can figure out, the parent function is the dark black one. We're going to see how did each of these change. So the first one says, what will be the equation if you translate the graph down 3 units to this green one? See the green one here? So, I want to go down 3. And I'm going to go back to the one we did right here. Remember when I added the plus 1? It moved it up 1. Adding a number to the end of a function moves it up. Subtracting a number from the end of the function moves it down. So the equation for moving it down, this one right here, would be, we still have to keep the absolute value signs. On your keyboard, right above the Enter key, there should be a key that if you go Shift, you'll make a straight line. That's what I use. So I still need the same function, which is the absolute value of x, and then this time I have to go down 3. So I don't put the 3 in the absolute value bars, I just put it after it. So I took care of the green one. Now the next one says, for the purple, if you translate it right to, let's find that one. Oh, it's right here. I have to get out of my text box. There we go. So this one. So remember, we started at the black and we moved it right to. So this time, when I write my equation, come on, when I write my equation, the change is going to go inside of the absolute value bars. Because if I put it afterwards, then it moves it up or down. If you put it inside, then it moves left or right. So you might think that it's y equals x plus 2. Let's graph that and see if that ends up right on top of this purple one. Remember the purple one? Here's the purple one. It should end up in the same exact spot. Let's try. Okay, graph, plot new function, y equals absolute value of x plus 2. Okay, yeah, that's what I wanted. Let's graph it and see what happens. Hey, it's not in the same spot. That actually moved it to the left, not to the right. I'm going to undo that because it was wrong. Let's try changing that to a minus sign. And I can check it because I can graph it. Let's see, y equals absolute value of x minus 2. Remember, we want it to end up on that purple. Yep, that's right. Now it's on the purple. That is the equation. Right there. It goes right on top of that purple one. Y equals absolute value of x minus 2. And I'll do that with the other ones. I want to reflect it. Let's see. Here's the reflected. Reflected about the x-axis. We talked about that. Reflecting about the x-axis is when you put a negative in front of your function. So for that one, all you're going to have to do is keep the original y equals absolute value of x exactly the same, except put a minus sign in front of the absolute value bars, and then you can check it with Sketchpad. If you want to translate the graph left 4 units, you'll do the opposite as what you did to translate it right. Remember, we subtracted 2 to translate right. You would add a number to translate left. And then when you want to vertically stretch the graph, then that's this one here. To vertically stretch, you will multiply by a factor of whatever they tell you. And we did something really close to that one. Here, this is y equals 2x squared. Well, it's not the absolute value, but you can see that that was a vertical shrink, just like they're asking us to do. And then the last page has the same kind of questions, except this time it's with the quadratic. But you're going to do the exact same thing. In fact, these are very similar questions to what they were on the previous page, except you're going to use y equals x squared instead of y equals absolute value of x. All right, so work on that a little bit longer and see if you can figure this out. This will be a great tool for as you continue with geometry and algebra 2, being able to use Sketchpad to check your work as you go and to know how a function has been transformed. Thank you very much.